Hey chaps, I hope you're all well. Today we're going to be in for quite a bumper of an episode, and same in the next one as well, while we churn out a lot of code, so we can finally get those tiles onto the tile map from the editor, which I can't wait to show you. So it's going to be a couple of long ones, but we're going to get a lot done, so please bear with. We're looking at maybe half an hour an episode or something like that, but we're going to get a lot done so I can show you some progress and make you feel like you're doing something. So without further ado, let's just jump straight into Visual Studio. So following the developing theme of the series, we're going to kick off today's episode with a small piece of refactoring work. We're going to finally move out the camera from the map class into the consuming classes in the game and editor respectively, so I can finally stop complaining and you guys can be happy. So let's just jump straight in and get that done. So we're going to open up the engine project, open up the map class, and here we have our good friend, the public orthographic camera. We're going to take this line, remove him, copy him out, and we're going to delete those few lines, and we're going to go to the editor project, right click on MonoGame editor, view code, and we're going to paste him at the bottom here. We're going to change this public to private, and we're going to change this C to a lowercase c. Now you might be thinking it may have been easier just typing that out instead of copying it and going through all that debacle, but I do like copying them line for line or section for section when I'm refactoring, just to make sure I'm not losing anything along the way. Okay, so with that done, we need to go back to the map class and find out what we need next, and that is the constructor of the camera. Now you'll see here also, whilst we're here, if I click on device in Visual Studio, it highlights graphics device in the constructor, and you'll also notice that is the only place that it highlights. So that means it's the only place we're using it. So because we're moving out the constructor of the camera, we can also delete this from the constructor of the map. So if we just remove that from there, copy this out, tidy up the few lines remaining, head back to the editor control, and in here under initialize, underneath find form, we'll paste that in. We'll change this to a lowercase c, and we'll copy this graphics device here because it's called something different instead of device, so we'll paste that over there. Okay, and then we'll also notice that we don't need graphics device in the map constructor either, so we can remove him. You'll also notice in the create map method underneath we have the constructor of map, so we can also remove graphics device from there. Okay, heading back to the map class, the only other place we need the camera is in the draw method, which we need to change this to a lowercase c and pass in camera as part of the draw call. We could pass in orthographic camera here and that will work, but I'd like us to pass in something a little bit more generic and not tie us into an orthographic camera. Although it doesn't make a great deal of difference, I just like it because it feels a bit more open. So what we're going to do is pass in a camera vector 2. Okay, and a camera vector 2 is what the orthographic camera is, so that will still work. Heading back to the MonoGame editor control, the other places we need to change are mymap.camera, mymap.camera, all the references to mymap.camera, and there's some more down here in handle viewport size change. So we'll do a quick change in here as well. So we'll just do a quick edit, and we'll do a find and replace, find in files, run this on the current document. We'll change this to replace in files, and we'll find mymap.camera, and replace this with just camera. Okay, replace all. Okay, tells us how many it's replaced, and that's looking pretty good. The only other thing we need to change is the use of our draw call here, and we need to pass in camera. Okay, so that should sort out the editor project. Of course, we have the game project to resolve, so let's go do that now. Head over to the game project, open up main game, and of course we need to create the camera in here too. So, back in the editor control, if we copy this line out here, paste that back into main game, we'll be missing a namespace, so we need to control period, enter, and then of course we need to construct the camera too. So let's head back to the editor control, copy this block of code, and in the game class we'll do that just after the map instantiation, and we'll change this because we do not need the zoom, we don't have a zoom in the game, so we'll just remove that block. And then the constructor for the map just needs to remove graphics device as we did in the control. mymap.camera should just become camera, and then mymap.draw should also pass in the camera. So let's give that a quick build. all looking good. Let's run the editor. We can still drag, we can still zoom, we can still click on tiles, we can still maximize and restore fine. Okay, so the editor's looking good. Let's right click on the game project, debug, start new instance, and make sure the game's still working. Now remember the game only had keyboard navigation, so if I use the keys, that's all looking good as well. Okay, so let's close all this down. That pretty much ties up our refactoring task. So let's get working on adding some new features. The first of which is going to be a common way of locating and loading content. Whilst the editor does provide a browse button for locating and loading a tileset image, a tileset is of course going to be much more than an image moving forward and will in fact be a collection of images within it. Above all, the game will of course not have this browse functionality, so the editor and game both need to know where to find this tileset data. Which brings us neatly onto the bootstrap. The bootstrap will be a simple engine controlled class which is in charge of how to load the data, but can allow itself to be told where to load the data. So let's jump right on in and get this bootstrap created. So he's going to be a class that lives in the engine. So if we open up the engine project, right click, add new item. This wants to be a class. I'm going to call this bootstrap. Okay. He needs to be a public class because he needs to be accessed from the engine and the game alike. And he's going to have a very simple constructor. This constructor is going to take a string called content path. Okay. We also want to store that as a member variable. And then we'll just set that in the constructor. Okay. So let's leave that as is for now and come back to it in a second. Head over to the editor project. Right click on MonoGame editor. View code. And we want to create an instance of him at the top here. So bootstrap. And then we'll instantiate him just before the map. And then of course it will ask for its first parameter, which is content path. So we need to work out what the content path should be. We are in the editor of course, so let's have a quick look. So if I open up the File Explorer, we can see we have the project layout here, we have the engine, the editor, and the game. Now if you have got the GitHub repo checked out, you will also have a content folder here. In content there is tilesets, and then you have the two tileset images. So really we want to be able to tell the editor, look, here is where you want your content to load, and then of course we want the game to do the same thing, but we'll come back to that at a later date and focus a little bit more on the editor today. So in the editor, we want to know where to load this content from. And to do that, we need to work out where we're running the code from as well. And where it runs from is in the editor folder here. We're in the bin and then debug. So when we hit the start button on Visual Studio, this is the executable file that is running. So we need to make our way back to the content folder. And to do that, we need to jump up a few levels in the directories. So we jump back 1, 2, 3, and then we have the content folder. So we need to jump back 3 levels and then go into the content folder. And how do we do that as a string in C#? Well, it's relatively simple actually. So if we pass in the argument and then we type dot backslash, that jumps up 1 level. So we do that 2 more times and then content. Okay. Of course, we've got an error here because backslashes are in fact escape characters. So we can do \n, \r, etc. So we need to tell C#, look, this really is a normal string and these are really backslashes. And to do that, we just use the @ character. Okay, so that is error free now. There's one thing I'd like us to do before we move on, and that is of course make sure we have a backslash here at all times. But I don't want that to be required as part of using it. We want to make sure the bootstrap takes care of that. So just to make that happen, we'll head over to the bootstrap class and we'll add a private method, private void sanitize, and this may be spelled differently depending on where you're from. I'm going to use it with a Z, sanitize content path. And we'll call this method from the bootstrap constructor. Okay, so like I say, we want to make sure the content path has a backslash at the end at all times. It just makes using it a bit easier, and why not? So to do that, we need to check if there is a backslash at the end of the string already. So to do that, we just if content path dot last indexed of, if I can spell last index of backslash. I think we can use character as well, so we can just do that. In fact, notice using it as an escape character, so I might as well just go the whole hog, use a string. The last index of, so if the last backslash in the string is not the last character, so if we just get the last index of and compare it to the length of the string, content path dot length -1. Now I'm using a -1 because the index is of course 0 based, the length is not. Okay, and then if it's not the end of the string, we need to add one. So content path plus equals backslash, like so. Okay, so we can give that a quick test out now. So we can do that by putting a breakpoint on the last character here, the closing bracket here. Head back to the editor, and then we can put a backslash on, give this a run, and you should see this content path does have the backslash. It doesn't have two, so it's worth noting here this double backslash does represent a single backslash, because without this at character here I do need to type a double slash, so that you're seeing it basically as it is in the inspector. So that's one backslash, two backslash, three backslash, and then the one at the end. Okay, so let's close that down again. If I remove the backslash, it should of course then add one. This content path does in fact have a backslash, so that's working as intended. Okay, so we've now got a bootstrap in the editor. We are now telling it where it's going to find all the content. So we can then move on next to loading some actual tileset data from that directory. So to do that, we first are going to need a tileset class within the engine to store our tileset data. But first, when we open up the engine project, we'll notice we have the map and tile class sitting at the root level of the project. Now with the introduction of a tileset class as well, it probably makes sense to introduce a new namespace for the tile map behavior. So let's do that. So if we right click on engine, add new folder, we'll call this tile maps, and then we'll simply drag in map and tile to that folder. Additionally, we open up the map class, we'll just add a new section of the namespace, so the game engine.tilemaps to line up with the folder name, and then do the same with tile. And then give this a quick build, and behold the plethora of errors we then get. So this is obviously because we are not requiring that namespace where the tile map is being used. So if we just head over to the errors by double clicking on them, this will just be a simple case of control period, add this namespace here, much like we did with MonoGame extended, and then head to the next error and repeat. Okay, let's give that a quick build. Everything's now hunky-dory, so we can carry on business as usual. Of course, the next thing we need to do is then think about creating a tileset class. So let's go ahead and create him now. So if we right click on the tile maps folder we just created, we right click add new item, we'll create a new class called tileset. He needs to be public so we can access him outside the engine. And then we need to know a little bit more about a tileset. So the first thing we need to know about a tileset is what the image is, or what the texture is. And in MonoGame /XNA, this is known as a texture 2D. In our case, you can get texture 3Ds, but we need a texture 2D. And we'll just call this texture. And we'll miss the namespace, so after control period, add Microsoft XNA Framework Graphics. That is the one you want. Okay. With that said, we'll close this down, and we'll start loading some textures into memory. Okay, so when we head back to the bootstrap class, we'll add another method in here, private void load tilesets. Alright. The next thing we need to do is call this from our constructor. And then we need somewhere to store the tilesets as we load them. So to do that, we'll add a public list of tilesets. We'll call this tilesets. We'll make this a get private set, and then add the namespace for tileset by pressing control period. There we go. Private set just means only the bootstrap can set it. Anything publicly can access it. Hence the get. Okay, so what do we need to do to load tilesets then? So we know we have our content path. This points to the content directory. But if I open up the file explorer, go into the content directory, there is also a tileset subdirectory, and that's where we want to load our tilesets from. So in our private void load tilesets, we'll have another string. We'll just call this tileset path equals content path plus tilesets, and then we'll put a backslash in there as well, which means we'll need the at character. Okay, we don't need to put a slash there because we made sure in the sanitize method that it always had a backslash, and that's why it's good to have it there, so you can reliably know there's a backslash there. The next thing we need to do is pull out all the PNGs, in our case, out of that tileset path. So to do that, we'll get a list of strings. So the strings will represent the file names, and this will be the texture paths. Now to pull them out, all you need to do is look at directory dot, so you might need the namespace, control period, system.io, and this will be directory dot get files. The path will be the tileset path we just set, and the search pattern will be in a string asterisk.png, and that'll just pull out all the PNG files. It won't like this because it's expecting to return an array, but I like to work with lists, so we can just list that. Okay, that works the whole time you have the system link namespace up there. So if this doesn't appear, you may have to press control period, and then it'll ask you to add system.link. Okay, so we have our list of texture paths. Now we need to loop through them and create a tile set for each texture. Okay, so I'm going to go with a classic for loop. I equals 0, I texture paths, dot count, I plus plus. String texture path singular equals texture paths, I. Okay, so what do we want to do with this texture path? Well, of course, we want to load a texture for it. Okay, so the first thing we need to do is load that texture. Now, the thing is, we need quite a bit of information to load a MonoGame texture 2D, as I'll show you now. So if I type texture 2D dot, or control period, add the namespace first. If I type a dot here, it will allow me to load them from a stream, or using the constructor, it will allow me to create a new texture of a given size, but with no data in it. So you're probably wondering, how do we get that from a file? Okay, well, it's actually quite simple. We can probably put this in a method, but since it's the only place we're using it, we'll just write it in line for now. So to do this, all we need to do is type using, okay, stream, we'll just call this file stream, equals file dot open read texture path. Okay, and then we just get our texture using that stream, using texture2d dot from stream. Okay, so we'll store that in a texture in a minute, but to do that, we might as well just create the tileset instance as well. So we'll have a tileset. We'll call this instance just so it's clearer. New tileset, and then in the curly brackets for this, we'll set our texture equals to texture 2D from stream file stream. Oh, lowercase f. And that's complaining. Ah, yes, of course. That's complaining because we need the graphics device. Okay, so you'll notice in the Bootstrap we do not have a graphics device currently, but we are going to need one for loading textures. And of course, we're going to need it for other things moving forward as well. So it makes sense to pass it in via the constructor and store that much like we have the content path. So let's go ahead and do that now as well. So another member variable will have a private graphics device lowercase, and then we'll also expect that to be passed in the constructor. So you can highlight that, copy it, paste it in here, add a comma, and then we'll just do much the same as content path. This graphics device equals graphics device. Now, of course, we're going to get some complaints in a moment because the constructor where we're using it in the editor is not passing the graphics device, but we'll get to that in a moment. The other thing we need to do here in the stream is just pass in that graphics device we just defined at the top of the file, and there we go. Okay, the next thing we need to do is make sure we've created this tile set now, we need to add it to the list. So that's relatively easy as well. So just tilesets, add tileset instance. Okie dokie. What we'll do is to test this out as well, we'll add a breakpoint at the end here, give that a run to make sure it's found the tile sets we expect it to. But first we need to fix the error that's going to come from changing this constructor. So let's head on over to the editor project, open up the MonoGame editor control, right click view code, and then in here we'll have to pass in graphics device. Okay, that should be okay, give that a build. And now what we're going to do is, on the Bootstrap file, we've got our breakpoint here. We're going to give this a quick run, and in my case, it should find that there is an error. Why is that error? Tilesets. Oh, I haven't instantiated the tilesets. That's fine. So at the top of the file here, top of the load tilesets method, sorry, I need to instantiate the list of tile sets. I thought I'd already done that. Okay, must have deleted it or something. Or dreamed it. Anyway, instantiate your tile set list, add it to the list here, and then that list will be populated by the end of this method, if it's found what it's supposed to. Let's give that a start now. Okay, hover over tile sets. In my case, it has found 2, and there are 2 textures in there. One's 512 by 512 here. The other one is 64 by 32, so it's looking about right. But what we'll do is, just to be sure, is we'll close this down now, and we'll store a bit of extra information on the tile set instead of just a texture. We'll give it a name as well. So we can easily just pull the name from the file, which is what we're going to do initially, but later on we could pull that from an additional file as well, which describes the tile set in more detail. So you can give it descriptions and tags and things like that, whatever makes most sense to you. So for now, we're just going to head to the Tilesets class, open up the tilemaps folder, tileset, and then in here, we're going to add a public string name getSet. Alright, with that done, let's head back to the bootstrap class, and then here where we set the texture, we also now want to set the name, and we want to set this to path.getFileName without extension, texture path. So now let's set the breakpoint at the end of this method again, give that another run, and you'll see when I hover over tile sets up here, we have 2 tile sets again. The first one is full tile set, the second one is mini tile set, and they correspond directly to the names of these files without the file extension, as is alluded to by this here. You could just as well leave the extension in there just by calling getFileName. Okay, so with that said, let's close that down. We now have some functionality in our engine where it loads up tile sets, it stores them, so anything outside of the bootstrap can access them. The idea is the editor can then use that to populate a drop-down box, which will then allow you to pick tiles from that tile set, etc. So that's what we're going to do next. So let's close all these down and then make sure that's all building happily. Okay, so to create the UI element to allow us to select a tile set, we need to go back to the Form 1 designer. So if we right click on Form 1 CS, View Designer, and we need to make some room for it in here. So if I left click on our tile set previewer we created, and the browse button, let's shift and left click there. I'm going to use the down arrow to move that down a little bit, and then I'm going to use the toolbox and find a combo box, drag that into the window, and position that at the top here, aligned with the MonoGame editor control. I'm going to give that a bit more of a sensible name, so the bottom right for properties, give this combo box tile sets. Okay, I'm going to change the style of this ever so slightly because by default you can type into it, which I'm not going to allow off the bat. I'm going to change that by going to drop down style here and change the drop down list. So that makes you forced to make a selection rather than type one out. Okay, the next thing we need to do is populate that with data. So to do that, we could use the constructor of the form, but in doing that, the MonoGame editor control will not yet be ready, and thus the bootstrap won't be ready, and therefore we will also not have any loaded tile sets. So we need to wait for an event to fire, and that is the form load event. So if we click on the title here or anywhere on the form, click on the lightning bolt for events down the bottom right, we can double click on load here to then get the form 1 load event, and this happens after all the controls have been initialized. Okay, the second thing we need is to access the bootstrap. So previously we created him in the MonoGame editor control, but he is private. So if I right click on MonoGame editor, view code, here he is, he's private. Now it's good practice to make sure you keep things private unless absolutely necessary, because it just bloats the code and makes things a little bit harder to understand. It gets increasingly harder to understand the larger the code base. So we make this public bootstrap. I'm going to make this a capital B now, and then make it a get set. Okay, and then I'm going to make this a capital B as well. So hopping back to Form 1 CS, we now do a list of tile sets. We might need a couple of using statements here. So control period, system collections generic, yep, and the game engine tile maps, yep. So this be tile sets equals to MonoGame editor 1 dot bootstrap dot tile sets. Okay, the next thing we need to do is loop through those. So I equals 0, I under tile sets count I plus plus, and then we can add them to the list. Okay, but in hindsight, actually, I think I can just get away with typing combo box tilesets, items, clear, no, not clear, add range, tilesets. Okay, so that's expecting it to be an array. So if we try and to array that, that might just work for us. Okay, let's give that a quick run. Hit the drop down, and here are our objects. So you'll see here that the name didn't show up in the list. It's actually just a fully qualified class name, complete with namespace, which isn't very useful to us. What we need to do is override the toString method on the class to make it a little bit more comprehensible by a user. So if we close that down, head back to the tileset class over here in the engine. If we override toString, and then just simply make this return name, as that is what we want to see in the drop down. Close that down, give it another run, and we should see in the drop down that we have our full named tilesets. Full tileset and mini tileset both correspond to the names of the tileset files in the content folder. So lastly today, we need to add some functionality to the combo box such that if we make a selection from the drop down, it will then populate the tileset preview with an image of the tileset for us, much like the browse button did previously. To do that, we're going to head back to our Form 1 designer, find our combo box, and then in the bottom right here for the events lightning bolts, we're going to find selected index changed. Double click on there, we'll then generate an event handler like this for us. So the first thing we need to do is pull out that selected tileset. To do that, we'll create a variable called tileset of type tileset, and then we'll set this to combo box tilesets.selected item as tileset. What that'll do is it'll cast the selected item, which is in fact an object, to a tileset if it is one, or leave it as null if it is not, which is an entirely feasible scenario because if the selected index is set to -1, which is possible, it will then be null because this will be empty. So we need to account for that. So if tileset is null, we just return. Okay, the next thing we then need to do is set the tileset preview as image to the image of the tileset. Now previously, the image of the tileset came from system.drawing.image, as can be seen here, but now we have a MonoGame texture, which is a little different and not supported by Windows Forms. So we need to do some converting between them. To do that, we're going to add an extension to the tileset class in the editor project, because it feels most pertinent to do it there, as it is not part of the engine itself or the tileset. So what we're going to do is create a new folder in the editor project, right click, add new folder, and we'll call this extensions. In the extensions folder, we're going to add new item class, and we're going to call this tileset extensions.cs, and this just needs to be a static class. It does not need to be public because we're only using it in the editor. To add an extension method, you just type public static void. Rather, in this case, actually want to return a system drawing image, so we type image, control period, using system.drawing, and then what we'll do is just get image from texture. So imagine this is a method on the tileset. In here, we then pass in the tileset, so this is how it works as an extension method. So I type this tileset, control period on tileset to add the namespace, and that's all we need to do. Okay, so the only thing this method will be expecting is a return value, which we currently do not have, and this method itself will appear on the instance of the tileset, as I'll show you shortly. So to convert from a MonoGame texture to an image is relatively simple. We first just need to create a memory stream. So we'll create a new memory stream, control period to add the namespace, stream equals new stream, and in here we're going to then copy the memory of the texture into this stream so we can then create a system drawing image from it. So we get the image by tileset.texture, save as PNG to the stream, and then we just use the tileset.texture.width, tileset.texture.height. Okay, so that has saved the content of the texture to this stream. We can then use the content of this stream to create a system drawing image from it. So here all we need to then do is just return a new bitmap with the stream. As you can see, that is another overload of the constructor. So we just pass in the stream, and that needs to be a lowercase s. And that's all we need to do. However, there's going to be more to this in a moment. Okay, so back to the form 1 CS. So now we just take this code here, very similar to before. So tileset preview.image equals tileset dot. So the method isn't here right now, but if we type get image from texture, close bracket, control period on the extension method, and asked to add the namespace. Once that's added, it will then work. Okay, so let's give this a quick run. And now if we select a tile set from here, so full tile set, you'll see the full tile set appears, and you'll see the mini tile set appears if I select mini tile set. Okay, so there is one problem to this that I'll show you now. So if I quickly flip between the tile sets, so I select full, mini, full, mini, full, mini, and repeat for a few moments. Okay, you'll see over here on the right the process memory is causing a lot of garbage collection, which is bad. We want to reduce that as much as possible because we're leaving a lot of orphaned objects and we're creating a lot of unnecessary ones. But that's because if we close down the editor, in our extension we're just returning a new bitmap every time we select it. But what we could do is cache them so that it only ever creates a new bitmap the first time we select that tile set. So to do that, we'll create a dictionary in the extension static class right now. So we've got private static dictionary, and this will be a dictionary of texture 2D to image. And this we'll just call this the image cache, and we'll just instantiate it here as well. Oh, add the namespace for texture 2D, and that equals new. Okay, so there's our image cache. So the first thing we need to do is pull the texture out of the tile set, equal to tileset.texture. And then what we do is we check to see if the cache has that image. So if the image cache contains a key for that tile set texture, then we simply return that cached image. If it doesn't, however, we then need to create one, which we'll do here, but then we'll store that in a variable. So we'll store this in image equals new bitmap, and then we'll add that to the cache. So the image cache add tile set texture image, and then also return the image. Okay, so how this works is a dictionary is a very performant class which essentially uses a hash set, so you can always rely on the speed of this, and because we're using texture 2D, the default for texture 2D is it uses the reference of the object, so the key in this case will be that specific instance, so we don't have anything to worry about, and then that should just work. So let's give that another run now. Okay, if we select our full tile set, mini tile set, you'll also notice it'll be a lot snappier when I switch between them again after the first time. So it's using the cached version. Okay, do that a few times. And of course this isn't as important with smaller textures, but as you get to large ones, it's incredibly useful. Okay, you'll see over here on the right, I've triggered absolutely no garbage collection, so we know the cache is working correctly. Just one to look out for. Okay guys, so I think that about covers everything we need to do today. So we've got our drop down working. That's all looking good. The next thing we need to do in the next episode, which I will do tomorrow actually, is allow us to select individual tiles in here so we can then drop them on here, which should be relatively trivial now we've done a lot of this groundwork. So guys, I hope you enjoyed it today. Thanks for tuning in. Please subscribe if you are interested. I'm really appreciating the feedback, and I'm really enjoying the series as well so far, and I'm enjoying working on it a lot more recently. And I hope you are too. So thank you very much guys. I hope you've enjoyed it, and I'll speak to you soon.